Hello guys, how are you? I hope you all be okay. Take my best regards for you all. Actually, today we'll complete our previous lecture about the modes of heat transfer. سلاورس بطبيعة خوش تیوی ابروک اگر خود حس کرده با تمامتی دینم حاضر ما یا چوی درباره میثود و گواستن انرژی انرژیت گرماتیه ابروکه ده بحث حسابات توانه که calculation هر میثوده که یا سایت خوی تیم بدر خستنا هیت ترانسفر رایت ابروکه هم ده بحثی وانه که هر یک شوانا سامپلا که بسيط من سر هي. So first of all we have the conduction. As you see, this is the general law for calculating the heat transfer rate Q. With its unit is watt, or you can say joule per second. It means that how many joule of energy or heat is transferred per 1 second. K is the thermal conductivity of a material. As you know, each material has a specific thermal conductivity. So in the exam, I'll give you the thermal conductivity of material. A is the cross-sectional area with its unit square meter. Delta T over delta X, it is the temperature gradient. It means that changing the temperature with the distance. As you see, if we have here T1 and T2. So the direction of heat is from T1 to T2. As you know, with the increasing of distance, the temperature will decrease. So this is why we have the negative sign in the equation. So we have the general law. This is the general law for calculating the heat transfer rate in the case of conduction. Here we have the simple example about the conduction. The wall of a house is 7 meter wide and 6 meter high, is made from 0.3 meter thick. Thick brief with a thermal conductivity of 0.6 watt per meter Kelvin. And also we have the delta T or temperature difference on both sides of the wall. In the inside of the wall, we have the 16 Celsius, and the outside of the wall is 6 Celsius. Don't forget, be careful, dear student, you must change the Celsius unit into Kelvin in the law of conduction. So find the heat loss through it. The heat loss, it means that the heat transfer rate, Q. So in the conduction, you have the general law, Q is equal to Ka delta T over delta X. K is the thermal conductivity, which is 0.6 watts per meter Kelvin. A, it is the cross-sectional area, so you can multiply 6 meter by 7 meter. Delta T difference in temperature, but you must change this Celsius into Kelvin. And also delta X, it means that the thickness of the wall, which is 0.3 meter. So you can easily calculate the heat loss or the heat transfer rate by conduction. Here we have the convection. Convection, it means the transferring of heat or energy with the presence of fluid, any fluid like liquid or gas. Convection arvagosana germati energy preko fluideki liquid yanji gas bit. The general law for calculating the heat transfer rate is the Q is equal to minus HA delta T. Q is the heat transfer rate with the unit watt, or you can say joule per second. And also H, it is the heat transfer coefficient with the unit watt per meter square Kelvin. A, it is the cross-sectional area with the unit square meter. delta T difference in temperature. So we have the simple example about the convection. Calculate the rate of heat transfer by natural convection. As you know, we have two types of convection. We have natural convection and the forced convection. So here we have the natural convection. So the question is that to determine the heat transfer rate, which is made by natural convection, between a sheet roof of area 20 meter multiplied 20 meters. So here you have the area. If the roof surface temperature is 27 Celsius, and also the air temperature minus 3 Celsius, and the average convection heat transfer coefficient, which is H, is 10 watt per meter square Kelvin. So you have the general law for calculating the heat transfer rate in the convection, which is Q is equal to HA delta T. H is the heat transfer coefficient you have in the question, which is the 10 watts per meter square Kelvin. And also A, it is the cross-sectional area. You have cross-sectional area. And delta T difference in temperature, you have two temperature, but you must change this temperature from Celsius into Kelvin. And then you will get the heat transfer coefficient. Also, here we have the radiation. Radiation, it means the transferring of heat or energy by electromagnetic waves. So here we have the general law for calculating the heat transfer rate, which is emissivity radiation multiplied Boltzmann constant. You must know the Boltzmann constant, which is equal to 5.67 multiplied minus 8. You must know the Boltzmann constant. Multiply area and multiply difference in temperature. So this temperature is to power 4. T2 to power 4 minus T1 to power 4. So here we have also an example about the radiation. Consider a person is standing in a room at 20 Celsius. Determine the total rate of heat transfer, which is Q, from this person if the exposed surface area and the average outer temperature of the person are 1.6 square meter and 29 Celsius. And also emissivity radiation is equal to 0.95. So you have the general law in the case of radiation, which is equal to emissivity radiation multiplied by Boltzmann constant. You must know the Boltzmann constant, which is 5.67 multiplied 10 to minus 8. And also you have the area in the question, which is 1.6 square meter and difference in temperature. So you can easily calculate it, and finally you can get the heat transfer rate. So this is our lecture for today. البته اول ما گویی اگه خود حسکت اول سرچبی میثودت و گاستنا انرژی calculation اتمانا هریکش بانی آساقو و ادگاد example ها سمپل باور نگود پیوی مفایا که باشین جوار بگیرن اش اوان میثودت و گاستنا گرماتیم بزانن هریکش وان میثوداجی یا سایقوی های و هر یکی ما با example ها سامپل لسر بود و پیوی ما فای با هوانی و قطابیت پشتوی خود ادگر هوا بید و هر دم پاراستی بند